a cosmic nightmare, or a learning opportunity? Imagine looking up one peaceful evening at the full moon. It hangs there serene, a familiar companion in our night sky. Now, imagine that same moon beginning to drift closer, faster, with every passing day, growing larger and brighter until it becomes a threat. That's the premise we'll explore today. This isn't a doomsday script pulled from the pages of Hollywood, but a scientifically informed, creative thought experiment. What would actually happen if the moon, Earth's ancient partner in orbit, crashed into our planet? Could it even happen? And if so, what would the sequence of destruction look like? As someone who has spent decades immersed in science communication and cosmic phenomena, I'll walk you through this cataclysmic scenario using scientific principles, historical context, and a fair dose of imagination, all under the lens of educational analysis and commentary to comply with YouTube's fair use standards. The journey we're about to take isn't just about destruction. It's about what this kind of scenario reveals: the delicate dance of gravity, the fragility of life on Earth, and the astounding interconnectedness of all things in space. And most importantly, it's about curiosity. The very same curiosity that helped humans walk on the moon might also help us understand what would happen if it ever came crashing down. Why the moon matters more than you think. We often take the moon for granted. It's a comforting constant in the sky, a marker of time and tide. But the moon is far more than a nighttime ornament. It's a stabilizing force that makes life on Earth possible in its current form. Key roles of the moon. Tidal forces. The moon's gravitational pull is responsible for the ocean tides. Without it, marine ecosystems would collapse. Axial stability. It helps stabilize Earth's tilt, which moderates our seasons. Without it, we could face climate chaos. Natural clock. For ancient civilizations, the moon was essential in tracking time and guiding agricultural cycles. Cultural and psychological impact. The moon has inspired myths, calendars, poetry, and even psychological states. Hello, lunacy. It's embedded deep in human consciousness. In other words, the moon is not just a chunk of rock. It's a cosmic balancing act that Earth depends on. It's like the silent partner in a two-person dance who never misses a step. As we understand it today, without the moon, Earth's axis could wobble unpredictably over long timescales. This wobble could cause drastic shifts in climate, making it far harder for life as we know it to persist. In essence, the moon is both guardian and stabilizer, a silent protector of our biosphere. Could the moon actually crash into Earth? Let's start with the obvious. This is extremely unlikely under normal cosmic conditions. The moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. That means in a billion years, it'll be considerably farther, not closer. But what if, just once, the cosmic odds rolled snake eyes? 3 hypothetical triggers. Gravitational disturbance. A rogue planet or massive asteroid entering our solar system could disrupt the moon's orbit. Think of it as someone nudging the turntable playing your favorite record. Everything skips. Orbital decay. Reversed a drastic change in Earth's tidal forces could hypothetically reverse the moon's outward drift. This would require massive changes to Earth's rotation or internal dynamics. Direct collision. The moon itself could get hit by another celestial body large enough to knock it off course toward Earth. Essentially a cosmic game of billiards gone terribly wrong. While none of these are likely, they provide a foundation for our speculative adventure. In each case, the energy required to dramatically alter the moon's path would be enormous. Still, the mere possibility, even in fiction, raises important questions about orbital dynamics, planetary safety, and the need for deep space monitoring. The physics barrier, why it shouldn't happen. To even consider the moon crashing into Earth, we'd have to suspend several bedrock principles of physics. Conservation of angular momentum. The moon is in stable orbit because of its momentum. Altering this drastically would require enormous external force. Newton's laws. Objects in motion tend to stay in motion unless acted upon. The moon's motion is self-sustaining. Gravitational equilibrium. Earth and moon are in a delicate dance of gravitational balance. Laws of thermodynamics and mass energy conservation. Major violations would be necessary to arbitrarily redirect the moon without outside energy inputs. It's important to note that these laws are not just suggestions, They're empirical descriptions of how the universe operates, tested over centuries. Breaking them, even hypothetically, reminds us of the finely tuned mechanisms holding the cosmos together. What happens right before the impact? Let's say the moon is falling toward Earth. Here's what would happen in the lead-up. Days before, the moon appears larger each night. Tides become abnormally high, flooding coastal cities. Animal behavior shifts. People panic. Emergency response systems become overwhelmed. Hours before, gravitational anomalies wreak havoc on satellites. Volcanoes and earthquakes begin erupting from internal stress. GPS systems fail. The skies crackle with electromagnetic energy. The media begins its final broadcasts. Minutes before, sky turns red. Shock waves begin to ripple the atmosphere. Communication systems fail. Winds become hurricane force everywhere. Fires ignite spontaneously from thermal friction. Panic turns to chaos. This isn't just impact, it's global dismantlement of the Earth's surface before the moon even makes contact. The sheer gravitational pull of the descending moon would begin to rip Earth apart. The moment of impact. Based on basic gravitational calculations, the moon would hit Earth at a velocity of approximately 10.8 kilometers per second, or about 24,000 miles per hour. That's like taking every nuclear warhead on the planet and detonating them at once, several times over. Immediate effects. Global shockwave, a seismic pulse that fractures tectonic plates. Mega tsunamis, walls of water taller than skyscrapers race inland. Firestorms, atmospheric compression creates heat waves incinerating entire regions. Debris fallout, a rain of molten rock and metal chokes the atmosphere. Crustal collapse, the point of impact would likely destroy Earth's crust, plunging both celestial bodies into partial disintegration. This is extinction level by every measure. Not just dinosaurs, but everything. Even the atmosphere might be partially blown into space. Radiation spikes. The magnetosphere could fail. A timeline of destruction. Let's walk through what happens after the moon hits. 0 to 1 minute. Impact site vaporizes. Crust splits open. Shock waves reach other continents. 1 hour. Fires engulf the globe. Tidal waves collapse coastlines. Ash clouds darken the skies. Survivors, if any, are deep underground. 1 day. Atmospheric dust blocks sunlight. Temperatures plummet worldwide. A new ice age begins without warning. Photosynthesis halts. 1 year. Mass extinctions reach 95 to 99% of all species. Acid rain and toxic clouds poison surviving ecosystems. Human civilization? Gone. Maybe a few pockets of survivors underground. But Earth is no longer home as we know it. 100 years. Sunlight returns. Earth's surface begins to cool. Life reboots in the deep oceans or underground. If it can. Evolution starts from scratch. 1 billion years. Earth may evolve again, but under vastly different circumstances. No moon. No humans. Possibly no mammals. New evolutionary paths emerge, if any. Historical echoes, remember Theia? Roughly 4.5 billion years ago, a Mars-sized planet, Theia, is believed to have collided with Earth. The debris from that impact formed our moon. This wasn't just destruction, it was also creation. The moon may be a monument to a catastrophic past. So in some strange, poetic way, the moon crashing back into Earth would be the universe writing a full-circle tragedy. Planetary impacts are a cosmic reset button. They remind us that planetary systems are not static. They evolve through violence as much as through time. What birthed the moon might one day erase it. Could we survive? Let's be blunt, no. Unless humans were already living on Mars or inside shielded deep Earth bunkers with decades of supplies and energy sources, survival would be nearly impossible. Even then, what kind of life would it be? Rebuilding civilization without Earth's stable environment and moon-regulated systems would be a Herculean task. Agriculture would fail. Communication and travel would vanish. Energy would be scarce. The reality? This is total planetary reset. The last hope for humanity would be off-world colonies. Yet even those would only be temporary sanctuaries unless we had already mastered self-sustaining ecosystems. In other words, if we're not ready before the moon falls, we're done. why this matters, even if it won't happen. You may be asking, why entertain this at all if it's so unlikely? Because it teaches us about the fragility of life, the precision of celestial mechanics, the interconnectedness of cosmic bodies, the importance of space science and observation. These thought experiments, while speculative, help us understand the real risks, like asteroid threats, that are far more plausible. They also fuel imagination, science literacy, and awe, and they underscore why we must fund astronomy, space exploration, and planetary defense. Today, it's the moon in fiction. Tomorrow, it could be an asteroid in reality. Final thoughts from a lifelong science enthusiast. The moon isn't just a rock in the sky. It's a cosmic guardian, a relic of our planet's violent past, and a stabilizer of Earth's delicate systems. Imagining its fall is terrifying, yes, but also illuminating. If anything, this scenario reminds us that our place in the universe is both tenuous and precious. The more we understand the mechanics of the cosmos, the more we realize how miraculous our existence really is. So tonight, when you look up and see the moon, don't just admire its beauty. Thank it for keeping things in balance. And remember, in a universe governed by chaos and order, stability is a rare and beautiful thing.